Hi, today we're going to investigate quadratic sequences and I'll talk about what they are in a minute. First of all, I'm going to assume that you've already studied linear sequences and I want you to investigate the first difference of some linear sequences. Now, let me explain this. I'll do one example. So sometimes the nth term of a nth term of any sequence is given this notation, u with a little subscript of n. So if you want the first term, it would be u1, the second term, u2, third term u3, and the nth term un. So if I want to find the first term in this case, I could just substitute in n equals 1, because that's when n is 1. And I'm going to get 4 times 1, which is 4, plus 2, so I get 6. If I want the second term, I'll do 4 times 2, 8, plus 2, 10. Third term, 4 times 3, 12, plus 2, 14. The next one, you can carry on if you want. I didn't say how many to find, but the next one will be 18. And actually, we've already kind of looked at this. The difference is actually the same every time, and it's the number that goes in front. So it's 4, 4, 4. But I kind of wanted you to find that out by substituting in. So pause the video and try it for these other 4. Well, let me go through it now. So the next one is going to be 3, then 10, 17, 24. And it's actually going up in 7s every time. So this is called the first difference, because it's the first difference between terms. We'll talk about what the second difference is in a bit. Next one is going to be 3.5. You can get decimals, that's okay. Then 4, 4.5, 5. And here the first difference is 0.5 for each one. This one, 5 minus 2n. First term is going to be 3, and then it's actually getting smaller every time. 1, minus 1, minus 3. And the first difference is actually minus 2. Finally, this is a general nth term for a linear sequence. We're going to get a plus b, then 2a plus b, then 3a plus b, and you get the idea. 4a plus b, I can't fit that one in. So every time it's going up by a, and that's a general thing for linear sequences, and I suppose that's the conclusion. Each, or actually not each, the first difference is always constant. And more specifically is the coefficient, that is the number in front of the n. So coefficient of n, essentially. Okay, you don't need to write it quite so technically. The thing is just to recognize that it is constant and it's always the number in front. This one being minus 2. Good start. So we've looked back at linear sequences. What do you think a quadratic sequence is? Pause the video and have a think. What do you know about quadratics? What have you already studied? How could you possibly write down a general quadratic sequence or even an example of a quadratic sequence? Give it a go. Well, here's the answer. The nth term of a quadratic sequence takes the form un equals an squared plus bn plus c. So I've got this linear part from before, and actually I didn't mention this when I would have mentioned this previously when I looked at linear sequences, but linear sequences, if you plot them, they'll give you points that would fit on a straight line. Whereas the quadratic sequence, you've got this linear term in there potentially, but you've also got this quadratic term, and then you get a sequence that looks a bit like this. sort of follows a quadratic curve. You might not even get the bit going down, you might just get the bit going up, or you might just, it will, or actually it can also look like this, which is a negative quadratic. But here's the key term that leads to that. The highest power of n is 2. So an example would be just something like n squared, which will give you the square numbers 1, 4, 9, 16. But you can add you could have 3n squared minus 2n. You could have that. You could have 4n squared plus 1. You're allowed to not have the n in there. Or you could go for the full thing and have 3 terms, 5n squared plus, I don't know, 6n minus 10. These are all examples of quadratic sequences. So what we're going to do now is look at the first difference of some quadratic sequences and then also the second difference. You'll see why in a minute. Just a reminder, this un is notation for the nth term, and then we're given the actual nth terms here. So for the first one, I'm going to do this without a calculator. It's just my square numbers. 1 times 1, 2 times 2, 3 times 3, 4 times 4. I'm going to go through this one as an example. This is the sequence. The first difference then is just the difference between the terms. I've got 3, 5, and 7, and suddenly we see for this quadratic sequence we don't get a constant first difference. It's actually going up in value each time. And how many is it going up by? Well, that is if I find the difference between the first differences, which I'm calling the second difference, I actually see that it goes up by 2. We've got a quadratic sequence. The first difference seems to be forming a linear sequence itself. If we find the fifth term, then we'd expect it to be 9, and it is, which again is going up by 2. So that's something to think about. We seem to be getting a slightly different behavior for quadratic sequences. Have a go at these 4 to investigate the first difference and the second difference. No problem if you use a calculator. If you get stuck, then play a little bit and I'll go through another one. But give it your best shot. This is you kind of investigating, getting a feel for how we can deal with these quadratic sequences. Right, I'm gonna use my calculator for some of it and just use my head for others. So 2 times 1 squared is just 2 times 1. Add 4, I'm gonna get 6. I might then start using my calculator just to avoid making a mistake. Okay, so the next one is I get 12. 22. 36. So if I want to find the first difference, I can see that it's 6, 10, 14. Second difference is then 4, 4. And you could check another one, you will find out that it is 4 each time. Next one. I'm going to be a little bit cheeky now, and I'm actually going to use the table function to find it quickly. So I forgot what that is. One sec. There it is, number 9 on my calculator. Okay, so I can put in 2n squared plus 4. No, sorry, 3n squared plus n minus 1. But when I do it, I'm going to replace it by x. You don't have to do it this way. I'm just, it's when you use the table function to plot non-linear sequences, this is typically what you do. I'm just using x instead of n because that's what my calculator does. And then I'm not interested in that function. I want to start at 1, end in 5. That sounds good. And I'm going to get 3, 13, 29, 51. And 79. So I now see that the second difference is 6, and then 6, and then 6. All right, what about one with a negative in front of it? Eight, 2, minus 8, minus 22. I'll just write down the first. No, maybe I'll write down the next one. Minus 40. So this time we've got minus 6, then minus 10, minus 14, minus 18. Second difference is going to be minus 4 each time. And here goes, like, you can sort of see what's happening now. It is always constant. That's going to be our conclusion. You could write down that the first difference will form a linear sequence. That is actually always going to happen. The main thing I want you to take out though is that the second difference is constant. However, this time it's not the same as the number in front of the n squared like it was for the linear sequence. We said before the first difference, the coefficient of n gives you what the first difference is. This time it doesn't quite work. Can you see what is happening? Or maybe you can. If not, let's do this last example. So for the first term, I'm going to get a plus b plus c. So because a times 1 squared is just a, plus b times 1 is just a plus b plus c. If I substitute in n is 2, it's getting a bit trickier now. Okay, I'll go through this slowly. So a times 2 squared is a times 4. That's 4a. And then I'm going to have plus b times 2. I write that as 2b plus c. I'll actually run out of room, but the next one is going to be 9a plus 3b plus c. The first difference here is 3a plus b, and then we get 5a plus b. And it actually turns out that the second difference is going to equal 2a. Is actually twice the number in front of the n squared, and you see it over here. There's a 1 in front of the n squared. We get a second difference of 2. When it's 2, it's 4. When it's 3, it's 6. When it's minus 2, it's minus 4. When it's a, it's 2a. The second difference is constant. It is twice the coefficient of n squared. This is going to help us work out nth terms of quadratic sequences. Like, this is where we're headed. If I gave you that quadratic sequence, could you get back to that? Okay, that's not today, but that is coming up. And getting this understanding is crucial. Okay, keep going. Well done so far. We found out some amazing bit of maths in this first bit of this video. The fact that linear sequences, well, they go up by the same amount every time. That kind of makes sense, I suppose, because you've got constant gradients. If I go along 1, I'm expecting to go up by a constant amount. If you link it to graphs, that is. Quadratic sequences, not so obvious, I don't think. Actually, the first difference forms a linear sequence. The second difference is a constant and is twice the coefficient in front of the n squared. So we can use this to help us work out whether a sequence is quadratic or not. That's our next step. Before we start looking at how to find the nth term, can we work out whether it's quadratic? And let me go through one example. Like, actually, can you think about how you might investigate that, first of all? I'll give you a little moment. And this is what you can do. You can take it, your quadratic sequence. I'll go through first one, 1, 5, 11, 19. I need to take all the terms. I can't just take a few of them. And then I can investigate, right, so basically we know that if we have a quadratic sequence, then the second difference is constant. It actually turns out, and I haven't proven this, but if the second difference is constant, then it will be a quadratic sequence. When I say constant, I do mean non-zero actually, because technically the linear sequences, their second difference is also constant, but it's just 0. So yeah, constant but non-zero. So let's find out the first difference. Take your time, you can do a subtraction on the calculator if you prefer, and then we can see the second difference each time is 2. So the answer to whether this is a quadratic sequence is yes, because it's constant. So I want you to use this knowledge to say whether the rest of them are quadratic sequences or not. Some will be, some won't be. Okay, and you can't just stop at, say, the fifth one. You have to check all of them. Let me show you the answer to these. Here we go. So yes, no here, because it's going up by 3, 3, 3, 3, 3. It's actually a linear sequence. No, if it doesn't, the second difference is mostly constant, but then it just changes somewhere, it's still not a quadratic sequence. This one's an interesting one. It's going down and then up, but it is a quadratic sequence. Okay, I hope you're happy with that. Right, we can also use this knowledge to work out the next terms of a quadratic sequence. So if you're confident, pause the video, give this a go. If not, I'm going to go through it. Right, so we can work out the first difference here is 8, and then 14, 20, 26. Second difference is going to be 6 each time. So if I want to work out the next few terms, right, well I know that there's going to be 6 here. So the next one is I can add 26 to 6 to give me 32. And that will give me my next term. I can use these differences. It's going to be 71 plus 71 plus 32, which is 103. That's going to be my next term. I can do the same again. I can just keep going. The next one, the second difference is going to be 6 again. So now it's going to go up by 38. And it's going to be 100. I haven't done these in different colors, all of them, but it's going to be 141. That's my answer. Give it a go for these ones. Using the same method, this is what you should get. 37.49 for that one, 39.60. This one's an interesting one. Look, it goes 4, 5, then back to 4, but it is still a quadratic sequence because it is going it's going up by 1, then down by -1, and down by -3. It actually turns out that the second difference is -2, and you will get those as your answer. So we're using this knowledge, really crucial knowledge. That's the main learning point for today, to be honest. This second difference is always constant. Okay, this is really the last bit of the lesson. How can we distinguish between linear, quadratic, and geometric sequences? I'm assuming you've seen linear and geometric before. You might not have. You might be, just jumping straight into quadratic. But if you have seen them, then this will be a good question to think about. So here's the answer. So linear sequences, they have a constant first difference. That's the thing we looked at the start of the lesson. The second difference will then be 0. For quadratic, you get a non-constant first difference. Actually, you get a linear sequence for your first difference, but then a constant second difference. And geometric, you actually get a constant multiplier between terms. So just a reminder, geometric is things like, I don't know, 3, 6, 12, 24. It's not going up. You have to kind of be able to spot this, but I'm actually timesing by 2 every time. So you won't see the same kind of, I'm not going to go into the differences in here, but yeah, you should be on the lookout for that. If the first difference and second difference aren't making any sense, it's probably a geometric sequence. You might also want to think about cubic sequences. Maybe that's not for right now, but we know what linear ones have n in, quadratics have n squared in. What happens with cubic sequences? That's something to investigate. And really, that's the end of the lesson. If you do have any spare time, then I want you to think about how we can calculate the nth term of a quadratic sequence. So if I was to write down this one here, for example, could you tell me what the nth term is? Could you tell me what un equals an squared plus bn plus c is, where you give me the values of a, b, and c? That is a challenge, and it's something we're going to look at next lesson. But I leave it as an extension now for you, if you want to give it a go. Otherwise, just take the main learning points from today. Thanks.